Hello YouTube, welcome back to my channel. Today we're going to solve a pretty easy problem, invert binary tree. So we're given the root of a binary tree. We need to create an efficient algorithm to invert the tree and return its root. So what's the meaning of invert? So let's look at an easy example. Say we have a tree with just 3 nodes, 2, 1, and 3. So the idea of invert is that we need to keep the root as the same and swap its left child and right child, just like this one. So let's apply this idea into a more complicated one. So the same thing, we need to keep the root as the same and swap its child and right child. And for each subtree, we also need to keep the root as the same and swap its left child and right child, like this subtree. So same thing for the other part. We'll swap 3 and 1 and swap the whole subtree with each other. So basically, we can break down this problem into subproblems to conduct the process for its subtree, and we will just like keep going down to the very bottom and to swap every subtree and then return back to the root. So basically it's the idea of DFS, stands for depth first search. And there are two ways to implement DFS, an iterative way or a recursion way. For this problem, we will use the recursive approach to solve this problem. For a recursion, the first thing come to our mind should be the base case, right? So let's say we have just a tree with single node. And to apply the same idea, we'll keep the root as the same and check its left order and swap its left child and right child. So when we access to its left child, this node has no child, right? So we will return null. And same thing for the right child, we will return null. So in this case, we will know that this node has no children and we will just return. So this is the base case. Otherwise, we will conduct the swap process for its left child and right child, its corresponding subtree. All right, so let's see how we're gonna do this in the code. All right, so let's code it up. Remember, we will need to use a recursive approach to implement the DFS solution, right? So for the base case, we will check if the current root node is valid. If it's not available, we will just return. Otherwise, we will swap its left child and right child. In Python, we can simply implement this using this syntax. And then after swap, we will basically implement the DFS to explore its left subtree and the right subtree. So we will use a recursive way to call the function itself to explore the left subtree. Same thing to explore the right subtree. After we go down to the very bottom, and we will see that the 9 has no left child, so we will return. And the 6 has no child, and we will return. And then we will keep going up to its parent and going up to the root node. So basically, we will just return the root as the result for this inverted tree. All right, so let's see if it works. All right,